In this video, I'm going to do two more examples on separable differential equation. Okay, these two examples will need little more work than the examples I did in the last video. Okay, the first example is solve the IVP, means initial value problem, that is given by y prime equals to 2y square plus xy square and y at 0 is 1, and determine where the solution attains its minimum. So the idea here is you need to find out the solution of this, okay, and after you get the solution, you will get the particular solution, right, because you will be plugging in the initial values there, and then after you get that, you will have to minimize that. You have to find out the critical points and then do all those things again. Okay, guys. All right. So let us try to solve this first. We have dy over dt, or dx, not dt, dx. So dy over dx, right, equals to 2y squared plus xy squared, right? So let me divide by y squared. You will get 1 over y squared dy over dx, right, equals to, you get 2 plus x, and then, so as we discussed in the last videos, we are using the separation of variables, right? So we separate y on one side and then x on the other side. So I'll write dx in the differential form here. So 1 over y squared dy equals to 2 plus x dx, right? So now you integrate on both sides. If you integrate on both sides, what do you get? You will get negative 1 over y, right? Because how do you get that? You will do y to the negative 2, right? So what is the integral of that? It will be y to the negative 2 plus 1 over negative 2 plus 1, right? So that is y to the negative 1 over negative 1, right? So that is negative 1 over y. So equals to, the integral of 2 is 2, I'm sorry, so the integral of 2 is 2x, right? So equals to, integral of 2 is 2x plus integral of x is x squared over 2 plus c. Okay, now we need to use this formula, this initial condition too. So using y at 0 equals to 1, meaning when x is 0, y is 1. That's what it says. So what do you get? You will get negative 1 over 1 equals to 2 times 0 plus 0 squared over 2 plus c. So you get c equals to negative 1. You see that? So what do you do after that is you just plug in that value. So you will get, therefore, negative 1 over y equals to 2x plus x squared over 2 minus 1. Okay, so now we need to solve for y. Y is in the denominator, so let us write down this in the fractional form and then we'll flip that. So you get negative 1 over y equals to, so there is 1 in the denominator, there is 1 in the denominator, right? So what is that? Is 2 in the denominator. So 4x plus, this is x squared, right, minus 2. You see that? So what do you get? Therefore, negative 1 over y equals to x squared plus 4x minus 2 divided by 2. See that? So what is y then? Y will be, just flip that and multiply by negative sign. You can do like this. So let's multiply both sides by negative sign. What do you get? You get, this will become plus, this will become minus, right? That's what you get. So what is the value of y then? Therefore, y is equals to 2 over negative 2 over, you can write, x squared plus 4x minus 2. This is the solution. So we need to know where this solution will get minimum value. Okay, for what value of x this solution will be minimum. So one idea is you can graph it and then see where it attains the minimum value. So the other idea is you just find out the derivative of this. What is dy over dx? You need to use f over z, right? So the quotient rule, right? So if you do the quotient rule, what do you get? So this is f over z. So what is the quotient rule there? The quotient rule is, so the formula is g times f prime minus the derivative of that, right? Minus f times g prime, right? Over g square. You see that? So if you do that, you will get x squared plus 4x minus 2 times f prime is 0 minus f is negative 2 times g prime is 2x plus 4, right? Divide by the square of that. You will get x squared plus 4x minus 2 square, right? So what do you get? You get this thing will be 0. That will be 4x plus 8. 4x plus 8 divided by x squared plus 4x minus 2 square. Okay, so to find out the minimum value, we need to set that the first derivative equals to 0 and find the critical points, right? If you do that, you will get the numerator equals to 0, right? Because there is 1 in the denominator. If you do the cross multiplication, or if you multiply both sides by that quantity, then you will get 4x plus 8 equals to 0. So what do you get? This implies x equals to negative 2. This is the critical point where the function will take the minimum value. Okay, the solution will take the minimum value. So you can find out the second derivative, d square y over dx square. So what do you get? You get again the same thing. This is like f over z, right? This is like f, this is like z, right? So what do you get? You will just plug in that, and then what do you do after you find out that? You just find out that, okay? And what do you get in the and then you plug in x equals to negative 2. Find out that and plug in x equals to negative 2. You will get positive value. You will get positive. The reason is because the denominator will be positive, because when you do the square of that will be 4th, right? You will get positive value for that. And the numerator also you will get positive. Positive over positive will be positive value. Okay, so that says the minimum. Hence you can say, hence y of x attains minimum at x equals to negative 2. That's what you do. So this example was question number 31. Okay, so I want to do one more example from the book, that is question number 35. Okay, so let's do another example. It is question number 35. So this says that consider the initial value problem. So consider the initial value problem. The initial value problem is y prime equals to ty 4 minus y over 3, and then y at 0 equals to y sub 0, which is positive. This is not given. Positive is not given. Y sub 0 positive is not given. So this is what it is. Okay. Now again, so this is dy over dt, right? Oh, by the way, there are some more questions there. So number A is, it is asking determine how the solution behave as t tends to infinity. No. So it says determine how the behavior of the solution as t increases. Determine how the solution behaves as t increases, depend on the value of y sub 0. That's one thing. And then number B is suppose y sub 0 is, suppose y sub 0 is 0.5. Okay, find the time t, at which the solution first reaches at which the solution first reaches 3.98. So this is the question. Okay, so what we want to do here is we want to first solve. That means you can write dy over dt equals ty 4 minus y divided by 3, right? So what you want to write next is I want to write divide by y times 4 minus y. 1 over y times 4 minus y dy equals to t over 3 dt. That's what you get. Okay. Now see, you remember from Calc 2 we need to use the separate. You need to use the partial fraction to separate them, right? So what you get? You will get so 1 over y. This is 1 over 4 minus y, okay? And then you can write 1/4. If you simplify this, you will get that. So the actual method is you need to do the partial fraction. Do you guys remember how to do the partial fraction? You need to do 1 over y 4 minus y equals to a over y plus b over 4 minus y, right? And then you write this is equals to a times 4 minus y plus b times y over y times 4 minus y, right? And then you cancel that, you get 1 equals to a times 4 minus y plus b times y, right? If you take y equals to 0, what do you get? A equals to 1/4. If you say this equals to y equals to 0, you will get this term will be 0. You get 4a equals to 1. So a is 1/4, right? So this will be 1/4. And if you said y equals to 4, you'll get this term 0 and then 1 equals to 4y. Again b equals to 1/4. That's what you will get. Okay, guys. So equals to, oh, by the way, there is dy equals to t over 3 and then dt. Okay. So the next we do is we want to integrate on both sides. On both sides, you get natural log of y. Okay. So you get natural log of y minus natural log of 4 minus y, right? Why is that? Because you know, if the derivative of the denominator is on the numerator, then the integral will be log of the natural log of the denominator, right? But what is the derivative of 4 minus y? The derivative of 4 minus y is -1, right? But there is +1. So what you can do instead of -1, what you can do is you can do negative and then negative is positive, right? So you can write the integral of this part is natural log of the denominator and the minus is in the middle, right? That's what I'm doing here. Equals to 4 over 3 times, what is the integral of t? It is t square over 2, right? And then plus c. You can do that, right? So what you get on the left side is natural log of y over 4 minus y equals to, you get 2t squared over 3 plus c. Okay. So what I'm going to do next is I want to write this natural log into the exponential form. So you write y over 4 minus y equals to e to the, you can write, let's write on this as c1. Okay, let's write on c1, e to the twice t squared over 3 plus c1, right? You can distribute this as like e to the twice t squared over 3 plus e to the c times e to the c1, because there is plus in the exponent. So you write e to the this times e to the that one. Okay, so e to the c1 is another constant. I am going to write that as c. So y over 4 minus y equals to c times e to the twice t squared over 3. Now let us see what happens if y0 equals to 0. Okay, so if y of 0 equals to y0, if this value is 0, what will happen? That's what I'm going to show you first. Okay, then if you do that, then you will get t equals, you plug in t equals to 0 and y0 that y at 0 will be 0. So 0 over 4 minus 0 is 0. So you'll get then c equals to 0. If you said c equals to 0, the right hand side whole thing will be 0, right? In that case, y will be 0 as well. Hence y equals to 0. This is one solution if if the initial value is 0. Okay, so the next thing is let y0 equals to y sub 0 is not 0. If this is not 0, then how can you write this? You can write this as let me write down this, because I want to solve for y. I want to write explicitly for y. Okay, so how do you do that? I can write 4 minus y over y equals to, and then 1 over c e to the twice t square divided by 3. I can write this way. Okay, so how do you write on the left side? Left side will be 4 over y, and then minus y over y will be 1, right? Equals to 1 over c e to the twice t square over 3. And add 1 on both sides. You will get 4 over y equals to 1 over c e to the twice t square over 3 plus 1. Okay, so what you get after that is you want to swipe. By the way, this 1 is not in the denominator, so this should be on the plus 1 here. So plus 1. Okay, so if you do that, so what I want to do is there is 1 in the denominator, right? There is 1 in the denominator there. So let me write down that one more time. So 1 in the denominator. Now make the same denominator. What do you get? Is 4 over y equals to, you can write c e to the twice t square over 3, and then on the top you will get 1 times 1 is 1 plus c e to the twice t square over 3. That's what you get. Okay, now I want to solve for y. Okay, so just swipe the top and bottom again. So what do you get? Here I swipe top and bottom from here, right? Because I just put in the numerator, write the reciprocal of this and write the reciprocal of that. That's what I did here, and I'm doing the same thing here. What do I get is, so you get y over 4 is equals to c e to the 2t square over 3 divided by c e to the twice t square over 3 plus 1, right? I'm just swiping the top and bottom. If you multiply both sides by 4, what do you get? You get y of t is equals to, oh, by the way, you can, let us divide both numerator and denominator by this quantity. If you divide numerator by this quantity, you will get 1, but you multiply by 4, you will get 4 divided by, if you divide the both of the terms in the denominator by c e to the 2t square over 3, you will get 1 plus 1 over c e to the twice t square over 3. That can be written as, this can be written as 4 over 1 plus, let's say that is k is 1 over c is k, okay? And then you move that to the top, you will get e to the negative twice t square over 3. That is the explicit expression for y sub t, okay? So what is the value of k? So using y of 0 equals to y0, we get, what do you get? You get y sub 0 is equals to 4 over 1 plus k, right? Now if you solve this for k, what do you get? You get 1 plus k equals to 4 over y0. What did I do? I multiplied by 1 plus k on both sides, and then I divided by y0, right? And subtract 1, you get k equals to 4 over y0 minus 1. That's what you get, the value of k. Okay, so this value of k can be positive or negative, and then the solution of this depends on these values of k. Where does that solution go in t tends to infinity? Depends on that. Okay, so that's what we are going to do the case. Okay, so the first case was if y sub 0 is 0, then the y is equals to 0 is the answer. Now we are assuming that y sub 0 is not 0, then y sub 0 is either positive or negative. If y sub 0 is between 0 and 4, okay, So assuming that y sub 0 is positive, and if it is between 0 and 4, then k will be what? K will be positive, right? Because if y sub 0 is less than 4 but greater than 0, then this quantity will be bigger than 1, right? This quantity will be bigger than 1, and then the whole k will be positive. If k is positive, then the denominator will be always positive, meaning that there is no, then the interval of validity will be all real numbers, right? So what I'm going to do now is, if 0 is less than y sub 0 is less than 4, let's do that. Then what happens? Then k is positive, right? This k will be positive. This quantity is always positive. K is positive. 1 plus positive. So the whole thing will be positive. So there is no case that the denominator will be 0. So the interval of validity is all real numbers, right? Thus, the interval of validity for yt is negative infinity to positive infinity, right? So we can take t tends to infinity. Hence, when t tends to infinity, see what happens if t tends to infinity, this will be e to the negative infinity. E to the negative infinity is 0, because e to the negative infinity is same as 1 over e to the infinity. So 1 over very big number, because e is 2.7, right? 1 over very big number, that will be 0. So when t tends to infinity, y sub 10, y sub t, what happens to y sub t? This will be 0. 0 times k will be 0. 1 plus 0 is 1. So 4. Y of t goes to 4. This is what you get. So the second case is, we are still taking y sub 0 positive. But what happens if y sub 0 is greater than 4? So the second case is, let us consider that y sub 0 is greater or equals to 4. Okay. In that case, what is the value of k? It was 4 over y sub 0 minus 1, right? So what happens here then? So when y sub 0 is greater or equals to 4, when this value is bigger than 4, this value is smaller than 1, right? This value is smaller than 1. And also, so the k will be this minus 1, right? So the smaller than 1 minus 1 value will be negative, but this whole k cannot be smaller than negative 1, because if y0 is very, very, very big, then it will be 0. So it can go up to negative 1. But if y0 is smaller number, like 4 or 5 or 6, like that, then it can go up to 0. That's why negative 1 through 0, that is the value of k. Okay. Now, so also we know that e to the negative 2t squared over 3, which is less than 1. Why? Because if t is 0, then this value will be 1. But if t is different from 0, then you get negative 2t squared over 3 will be less than 1. Okay. So let me write down what was our solution. Our solution was yt is equals to 4 over, you get 1 plus k e to the negative twice t squared over 3. That's our solution. Okay. Now look at this. Since this quantity is less than 1 and the k is between negative 1 and 0, so this product will be between negative 1 and 0. That's what you will get. Because see, if this is less than 1 and but positive, I can write this is like 0 is less than this is, because e to the any power is always positive. Okay. So it is greater than 0 and less than 1 because it has a negative exponent. E to the negative exponent is always less than 1. Okay. So now if you multiply this k and that, then what do you get? This will be the k times that will be negative 1 and between negative 1 and 0. That's what you get. Okay. Now if you add 1 on both sides, you will get 1 plus k e to the negative twice t squared over 3 will be positive. So this quantity, the bottom quantity, will be positive in this case too. Meaning that, what is the interval of validity? If it was 0, if there is a possibility of 0 here, then interval of validity will be different from negative infinity to positive infinity. Okay. So the interval of validity of validity is negative infinity to infinity. Hence, as t tends to infinity, because t can go to negative infinity to positive infinity, okay? If t tends to negative infinity or positive infinity, you will get this goes to 0 and that one also goes to 0. So 0 times 0, and so 4 over 1 plus 0, that is 4 over 1, that is 4. Then y of t goes to 4. Okay, so the next thing is the case 3 is if y sub 0 is less than 0, what happens? Then k will be, this quantity is less than 0, this is negative, so 4 over negative will be negative number minus 1 will be less than negative 1, because negative 1 minus something will be less than negative 1. Okay, so in that case there is a possibility to have vertical asymptote, right? This guy can be 0. If that is 0, then yt has a vertical asymptote. So we want to find out that. Okay, so there is a possibility of vertical asymptote, which means that is the interval of validity may be different from, or may not be negative infinity to infinity, right? Negative infinity to infinity, it may be smaller than negative infinity to positive infinity, because if there is a vertical asymptote, then there will definitely be the interval of validity will be different from that. Okay, so how do I find out the interval of validity then? For this we solve the denominator equals to 0 to find out the vertical asymptote. Okay, 1 plus k e to the negative twice t square over 3 equals to 0, and then solve for k. That's what we need to do. Okay, so if you solve this equation for t, what do you get? You get k e to the negative twice t square over 3 equals to negative 1, right? And then let me multiply both sides by e to the positive twice t square over 3. What do you get? You get k, that positive twice t square over 3 and negative twice t square over 3 cancel out, equals to negative. You get e to the positive twice t square over 3. That's what you get. Okay, so now solve for t square, take natural log. Okay, by the way, before that you need to multiply by negative sign on both sides. You will have negative and then positive here. So natural log of negative k equals to twice t square over 3. This implies multiply by 3 half, you will get t square equals to 3 half natural log of negative k. That's what you get, t square equals to. So what is t equals to? T equals to plus minus, you can write under the root 3 half natural log of negative k. Okay, so there is a plus value and minus value. So there are the two values of t where this solution is not valid. Okay, so now we need to find the interval of validity there. So this is the negative value, that negative root under that value. Okay, there is a positive root under that value, plus root under this just 3 half natural log of negative k, 3 half natural log of negative k. That's what you get. Since the 0 is in the middle, because this is positive and this is positive, this is negative. So this is the interval of validity, because y sub 0, this 0 falls here, falls in the middle, right? This is the interval of validity. Interval of validity is negative under the root 3 half natural log of negative k and positive 3 half natural log of negative k. This is the interval of validity. Now the thing is, so we cannot take t tends to infinity in this solution, because the interval of validity, when y sub 0 is less than 0, then you cannot go to infinity. You can go at most to this point. From the left, okay, so from the left you can go to that point. From the here you go from the right, you can go to that point only. Okay, that is the minimum and the maximum values of t you can take. All right. So let us see what happens if when t tends to this number from the smaller values. So when t tends to this number from smaller values, meaning that when t square goes to this value from the smaller number, right? Or you can say when e to the negative 2t square over 3 times k, okay, goes to what? From -1 from the smaller number. You can just go back and then see. So at that time, this whole value goes to -1 from a smaller number, right? Meaning that like -1.1, -1.001, and so on. So you can say that when t tends to root under 3 over 2 natural log of -k, the t can go to this from the smaller number, from that side, from the left side only. Smaller number means do you remember the left limit and the right limit? I'm just writing because it is going from the left to that number, so I'm just denoting that. In that case, this is same as saying t square going to that from the smaller values. And so go back. So 2t square over 3 is going to natural log of -k. So e to the 2t square over 3 is going to -k. And then this guy is going to -1. So meaning that this whole guy is going to -1. Then k e to the negative twice t square over 3 is going to -1 from the smaller values, meaning -1.1 and so on. Okay. -1.1, -1.001, -1.0001, and so on. In that case, the whole denominator, that is the whole denominator 1 plus k e to the negative twice t square over 3 goes to 0, because this is you can add on 1 on both sides, right? Going to 0 from negative values. It is going to 0 from the negative value. So this is 0 but negative from negative value, meaning that this 4 over that thing will go to negative infinity, because it will be 4 over -0. That will be negative infinity. Hence, y of t is going to negative infinity. So that's the all answer, right? This is one answer. This is another answer. And that one is another answer. So when y sub 0 is 0, then y is 0. When y sub 0 is greater than 0, there were two cases, right? One case we consider between 0 and 4. The another case we consider greater or equals to 4. So in both cases, this is going to 4. And if y sub 0 is less than 0, then it is going to the solution going to negative infinity. Okay. So the second part of the problem is, suppose y sub 0 equals to 0.5, then find the time t at which the solution first reaches 3.98. Okay, let's say this is then find the time t at which the solution first reaches 3.98. What is given is y sub 0 equals to 0.5 is given. What was our solution at the very beginning? We got y over 4 minus y equals to c e to the 2t square over 3. That's what we got, right? So if you said y sub 0 equals to 0.5, you get 0.5 over 3.5 equals to c, right? So what is that? So 0.5 over 3.5, that is 1/7, right? So c equals to 1/7. So what is the solution at that time is y over 4 minus y equals to 1/7 e to the twice t squared over 3. So the question says that find the time t at which the solution first reaches 3.98. So what we can say is let t1 is the time at which the solution first reaches 3.98. Then you can write 3.98 over 4 minus 3.98 equals to 1/7 e to the 2t1 squared over 3, right? So we need to solve for t1 here. Okay, guys. So what you get here is 3.98 divided by so 4 minus 3.98 will be 0.02, right? So equals to you get, let's multiply by 7 on both sides too. So you get 7 here too. So and then times 7 will cancel out, right? So e to the 2 t1 squared over 3. Take natural log. You get natural log of 7 times 3.98 divided by 0.02, right? Equals to 2 t1 squared over 3, because when you take the natural log, you get natural log of e is 1, right? So this goes to be for the log, so that's what you get. So now multiply both sides by 3/2, you get 3/2 natural log 7 times 3.98 divided by 0.02 equals to t1 squared, and take the square root on both sides. So basically, if you find out the value of the left hand side, this is what you get. You get t1 squared equals to 10.8588. So if you take the square root, so the t1 will be square root of that, okay? So square root of 10.8588 is 3.2952. So 3.2952. So this is the time at which the solution reaches the height of 3.98 for the first time. Okay guys, thank you. That's the end of this problem.